Bismillahirrahmanirrahim. Today we are going to solve Cambridge O-Level Physics Paper 2 Theory. We have a subject code of 5054 and the paper variant is 22. For the session of October-November 2023, we have 1 hour 45 minutes for this paper and instruction carrying the important information of G. The value of G is 9.8 meter per second square, and we are allowed to use calculator and we can use HP pencil as well. We have 80 marks for this paper. So we're gonna start our paper from the question number 1. Question number 1 is that velocity is a vector quantity but speed is a scalar quantity. State how a vector quantity differs from a scalar quantity. We know that scalar quantity required only magnitude for their description, but vector quantities require direction and magnitude as well. So vector quantities are those quantities that have direction and magnitude, but scalar quantity has only magnitude. So we need to write this information. Vector quantity has direction and magnitude, but scalar quantity has only magnitude for their description. Underline all. Part B is underline all the vector quantities in the list: acceleration, distance, energy, mass, momentum, and temperature. So acceleration is a vector quantities, and distance is scalar, energy is scalar, mass is scalar, momentum is again vector quantity, and temperature is again scalar quantity. Part C. Okay. Figure 1.1 shows a passenger running across a large ship at a right angle to the direction in which the ship is moving. This is a passenger and is moving due north and due east and is making 90 and 2.4 meter per second is his velocity, and the ship is moving due east at 6.8 meter. The passenger runs across 2.4 meter per second. The large ship is traveling due east at 6.8 meter per second. Determine either graphically or by calculation the resultant velocity of the passenger. Give the direction in which the passenger is moving relative to due north. Show how the answer is obtained. Okay. So there are two methods to calculate it. One is from the graphical and one is through calculation. So first I am going to solve this question by calculation. Then I am going to solve it by graphical method. So first I will choose method number 1 is for calculation. This is a simple method. Both these methods are actually easy method and they are the concept of vector addition and obtaining resultant vector. Okay, first I'm going for method 1. I'm gonna use Pythagoras theorem. So this is how I'm going to apply it. Passenger is moving 2.4 meter per second and the ship is traveling at 6.8 meter per second. We need to find the resultant vector, which would be this. We know that this is 90 and this is theta. So we're gonna apply Pythagoras theorem. Resultant vector would be perpendicular square plus base square 2.4 square plus 6.8 square After taking square root of this, the answer would be 7.2 meter per second. This would be our resultant value. We're gonna write over here 7.2 meter per second. Now we need to calculate angle from due north. Okay, for the calculation part, we're gonna calculate the angle like that. Tangent theta is equal to perpendicular over base. Perpendicular is 6.8 and the base is 2.4. I'm going to take the inverse of tangent. Theta is equal to tangent inverse 6.8 over 2.4, and the answer gonna be 71 degree. So I'm writing over here 71 degree. Now this was the simple question. This is how we calculate result. Now I am going to use method 2 just for your understanding, because I know some student will find this method a bit easier compared to first method, and some student will find the earlier method was a bit easier. It's your choice. Whichever method you will use, examiner would give you full advantage. So use wisely and choose wisely the method suited you, which method suited you the best. Now method number 2. For method number 2, we're going to use the graphically. We need to apply the scale. Scale would be 1 centimeter is equal to 1 meter per second. So I'm going to make the line of 2.4 centimeter, that is due north, or this is 2.4. Now I'm going to put 6.8 centimeter due east. This would be 6.8 centimeter. This is our arrowheads. Now you need to complete it by compass. 2.4 centimeter line, sorry, this is 2.4 centimeter line. Now you need to open 6.8 centimeter. And put your compass here. So where the two lines intersect, we're gonna plot over resultant vector. First we complete parallelogram method, the shape of this. Now you need to measure the length of the rectangle diagonal. This is how you're gonna measure it. As you can see, the line is making exactly 7.2 centimeter. So this would verify our answer as well, which we already calculated. And by measuring the angle from the D, you will find this 71 degree. I can show you as well. So this is how I'm gonna show it, 71 degree. Okay, so This, you only have to choose one method from these two methods. Now we will move to the question number 2. Question number 2 is a spacecraft of mass 300 kg in a straight line in a space at a speed of 8000 meter per second. Calculate the momentum of the spacecraft. We know that the formula for the momentum is the product of mass into velocity. Mass is given as 300 kg and the velocity is given, that is 8000 meter per second. So after multiplying it, our answer would be 2.4 into 10 is to power 6 kg meter per second. So we're gonna write over here 2.4 into 10 is to power 6 kg meter per second. Now we will move to the part B. The fuel on the spacecraft explodes and the spacecraft splits into two parts. The direction in which the parts move does not change. After the explosion, the speed of the front part increases to 9,000 meter per second. It has a mass of 150 kg. Calculate the speed of the rear part after the explosion. So we know that explodes and the split into the two parts. The direction in which the two parts move does not change. After the explosion, the speed of the front part increases from 9,000 meter per second and it has a mass of 5. We need to calculate the speed of the rear. So we know that we have to apply the law of conservation of momentum. What is the law of conservation of momentum? Is that momentum before collision and after collision must be equal. So we calculated before collision, that was the momentum was 2.4, and now we need to see what is going to be after is equal to before, and or you can say P2 is equal to P1 and M1 V1 plus M2 U2 is equal to 2.4 into 10 raised to power 6. We know that mass is 150 into velocity is 9,000 and mass of 150, and we have to calculate this V2 velocity. I'm gonna multiply it this and subtract from other 2.4 into 10 raised to power 6 minus 1.35 into 10 raised to power 6, which you would get after multiplying it. After solving it, the answer would be 1.05 into 10 raised to power 6. Now 150 V2 is equal to 1.05 into 10 raised to power 6. We're gonna divide 1.05 into 10 raised to power 6 divided by 150. The answer is 7,000. So our answer would be 7,000 meter per second. This is the question from momentum, and law of conservation of momentum is applied. B second part is the total kinetic energy of the two parts after the explosion is greater than the original state, the energy transfer that occurs in that explosion. We know that fuel has a chemical energy that would convert into heat energy, and after heat energy it would convert finally into kinetic energy. So you're gonna write over here that fuel has a chemical energy inside that converts into heat or converted into heat and then into kinetic G. The next part is the explosion lasts for 0.20 seconds. Calculate the average force on the front part during that time. Okay, we need to calculate the force. We know that the force has a formula of rate of change of momentum is equal to force. So we're gonna apply that. F is equal to rate of change of momentum, and the change in momentum would be equal to P2 minus P1 divided by time, and time is 0.2 seconds. So after putting those values, P2 is 150 into 9000, which we already calculated, minus 150 into 8000, or divide by 0.2, you would get 7.5 into 10 raised to power 5 Newton. So answer would be 7.5 into 10 raised to power 5 Newton. Now we will move to the other part of this question. No, next question, question number 3. Question number 3 is of center of gravity. From the topic of the center, a plane irregular lamina has a mass of 50 gram. It hangs from a nail. Okay, it hangs from the nail, passes through a small hole h near to the edge of the lamina. The nail acts as a pivot and the lamina can swing about it. The lamina is held in the position shown in the figure 3.1, a small distance above horizontal bench. The center of gravity of the lamina is G. Okay. The weight of the lamina is a force that acts downwards. Explain why the lamina experiences the downward force. We need to explain due to its weight, and weight is due to the gravity, that's why it experiences a downward force. So we're gonna write over it. It is in the gravitational field of Earth. So due to gravity or due to pull of Earth, it experiences a downward force. A downward force. For the next part, calculate the weight of the lamina on Earth. The weight of the lamina would be W is equal to mg, but mass is given in grams. This is mass. We're gonna convert it by dividing it by 1000 into kg. So 50 divided by 1000. From the question paper, we know that the value of G is 9.8. After solving it, the answer would be 0.49 Newton. So I'm gonna write over here 0.49 Newton. This is a simple question of weight. Now we will move to its B part. Okay, the weight that produces a moment about the pivot H. Using figure 3.1, calculate the moment of the weight about the pivot. We know that moment is equal to force into momentum. So what is going, the pivot is at H, so we have to take our moment as 8, and force is is given, force we have calculated in the earlier part, that is 0.49. So we're going to use this for 0.49, and we're going to use this, the perpendicular distance, as moment arm for calculating moment. So the formula for the moment is force into moment arm. force into moment arm. You can write it dF is equal to 0.49 and moment arm is given in 8 centimeter. You're gonna divide by 100 to change into meter. So the answer would be 0.039 Newton meters, or you can write 0.0392 Newton meter. So if you have to give answer in 3 significant figure. Okay, next part, I have already written the answer so I could explain it better. The lamina is now released from the position shown in the figure 3.1. Describe what happens to the lamina from the time it releases until it stops moving. Okay, we know that when lamina start to move, it it will move like that. Lamina, it will move like that. It will move in the clockwise direction, tick 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 tick, this way lamina gonna move. Weight of lamina produces clockwise movement. Because center of gravity is lower, then pivot lamina will swing about pivot. Amplitude of swing will decrease slowly and lamina will come to rest finally when the center of gravity will be exactly below that nail. So we can write over here. It is like that. I'm going to explain it. When the weight of the lamina produces clockwise movement. When the weight of the lamina produces clockwise movement, its amplitude start to decrease gradually, and until it comes to the rest, the center of gravity will be exactly below the nail. So we have to tell these, or you can briefly tell that lamina moves clockwise, speeds up first, then gradually slow down until it stops. Center of gravity will be vertically below it. So both are the right answer and both explanations are correct. If you write one of these, you would get 3 out of 3 marks. Now we will move to the question number 4. Question number 4 is from the topic of the pressure. Figure 4.1 shows a long vertical tube sealed at the base and open at the other end. The tube is 1 meter long. The cross section area of the tube is 4 into 10 raised to power minus 4 meter square. This is the area, and the density for the liquid is 1.4 into 10 raised to power 4 kilogram per meter cube. The base cross section area has 0.4 into 10 raised to power minus 4. The atmospheric pressure, which is also given, 1 into 10 raised to power 5. Calculate the total pressure in the liquid at the bottom of the tube. We need to calculate the total atmospheric pressure at the bottom of the tube. We know that the formula for the pressure is rho GH, and the total pressure would be equal to pressure of liquid plus atmospheric pressure. So we're gonna calculate rho GH plus atmospheric pressure is given 1 into 10 to the power 5 Pascal. So what is rho GH? The value of the value of density is given, that is 1.4 into 10 raised to power 4. So we're gonna write over here 1.4 into 10 raised to power 4, and the value of G would be 9.8, and the value of H is also given, that is 1. This is over here, the value of H is given 1 meter long. So atmospheric, after adding to atmospheric pressure, the answer would be 237,200 Pascal, or you can write 2.4 into 10 to the power 5 Pascal. So both are the right answer. The force extended sorry, the force exerted on the inside surface of the bottom of the tube. So we're gonna find out the force formula for the pressure is P is equal to F over A, and for the force the formula would be pressure into area. What is pressure? We have already calculated in the first part, 2.4 into 10 to the power 5. And what is area, which is given 4 into 10 to the power minus 4. We have to use this area, not this area. Both the areas were the same. Okay. The answer would be 96 Newton. Okay, 96 Newton is the answer. So we will move to the next part of this question, part B. This first two parts of the simple calculation of pressure, the formula we use rho gh and force over area. Now its other part is okay, this is the other part, B part. A small sheet of glass is placed over the open end of the tube. I'm going to show this is the open glass. The tube is inverted, it means upside down. The open end of the tube and the sheet of the glass are at a short distance below the surface of the liquid. Figure 4.2 shows the arrangement: inverted tube, dense liquid, sheet of glass, and the container. The sheet of glass sees the open end of the inverted tube. Describe what happens in the inverted tube when the glass is removed. Okay, when the glass is removed. Okay, first I simply explain. When the glass would remove, the liquid would put down, and here the level would increase. How much the liquid would apply its weight, it depends upon the density. So we're gonna write over here the answer is, which I already written, is that level of the liquid in the tube falls because we have removed the lid. After some time it stops falling and becomes stable. It's gonna decrease when we remove the glass, but after some time it stops falling and becomes stable. Original pressure at the bottom of the tube greater than the pressure of the liquid in the basin. So the original pressure and leaving a vacuum at the bottom of the tube. So the bottom of the tube will remain as empty as a vacuum would be created over here. So this is how when the inverted tube is removed from a glass. Okay, the level of the liquid in the tube falls. After some time it stops falling and becomes stable. Original pressure at the bottom of the tube greater than the pressure of the liquid in basin, leaving a vacuum at the bottom of the tube. Now we move to the next part, question number 5. No, we have third part is left. Okay, the equipment is used to make measurement, that is used to calculate atmospheric pressure. Describe the measurement made and then used in the calculation the atmospheric pressure. You may draw a diagram to help your description. So first I need to draw the diagram. This is the tube, this is the container, and this is the level of water. So the height we use in calculation would be this, from this surface to the this level. This would be our height. Okay, so first we measure the height of the liquid. Then we need we have to use the formula pressure rho gh density. Pressure rho is the density of the liquid, rho is equal to density liquid and h is height, and we know that g is gravity, which is 9.8. okay, this is how we completed question number 4. Now we move to the question number 5. Question number 5 is figure 5.1 shows a device that cools the air in a room by evaporation. This is a water container, grill fan, grill wet sponge block is like air cooler. Water drips from the container into the sponge block and keep it wet. Air flows in through one grill and out through the other. As the air flows through the wet sponge block, the water in the sponge block evaporates. When the water evaporates, the temperature of water remaining in the sponge block decreases. Explain. Okay, when we know that the concept of convection is used, when the high energy particles escape, the low energy particle will remain. So the low energy particle have less temperature, so their kinetic energy would be less, so the temperature would decrease. I will explain it again. When the high energy moving particles will escape, the low energy particles will remain in the liquid, and the remaining low energy particle will have a less vibration, less kinetic energy, so the temperature would be decreased. So temperature will decrease. Now we move to the other part. Explain why energy is needed when the water evaporates. When the water evaporates, work is done in moving particles apart. Energy is needed to overcome the force due to atmospheric pressure. Either of two explanation, or you're gonna write either one. How make the explanation is correct. Work is done in moving particles apart. So this is our right explanation. Other part is other, you can write energy is needed to overcome the force due to atmospheric pressure. Now the B part. State two ways in which evaporation differ from boiling. You can write these points that evaporation occur below boiling point and boiling occur at boiling point. Evaporation occur only at the surface and boiling occur throughout the liquid. Or evaporation, during evaporation temperature drop, but we know that during boiling temperature doesn't change. So you can write any 2 point. I am going to repeat my answer, or I am going to read my answer which I have already written over here. Evaporation occur below boiling point and boiling occur only at boiling point. Evaporation occur at surface of the liquid while boiling occur throughout the body of the liquid. And the third part is evaporation temperature drop, and but during boiling the temperature doesn't change. So this is our B part. Now we will move to the question number 6. Yes, question number 6 is about the loudspeaker and about the frequency. The loudspeaker in figure 6.1 produces a sound frequency of 8,800 hertz. Loudspeaker sound. State what is meant by frequency. First part is what is frequency is the number of vibration per second is known as frequency. So we're gonna write over it number of vibration in unit time. Number of vibrations in unit time, or you can say frequency is equal to number of wavelengths. Both these answers are correct. Explain whether the sound produced by speaker is audible to a human with healthy hearing. We know that audible frequency range is 20 hertz to 20,000 hertz. 20 hertz to 20,000 hertz, and 800 hertz, which was given in this question, is within this range. So we're gonna write over here, he will be able to hear the sound of, he will be able to hear sound of 800 hertz because it is within the range. Now we will move to the next part. Describe the motion of cone in figure 6.1. Explain how this causes the production of sound. We know that sound is produced by the vibration, and vibration sounds are the waves of longitudinal, and longitudinal waves require medium to travel, and longitudinal waves have compression and refraction. In compression the particles are closer, and for refraction the particles are apart from each other. So we're gonna write over here, cone will vibrate when it moves forward, it produces compression, or when it moves backwards it produces a rarefaction. Vibration changes and pressure pass on the neighboring air, so the particles will vibrate in this direction forward, the compression, and it will move backward, it would be rarefaction. So this is how they pass the energy to their neighboring air particle. The sun is a very large, extremely violent ball of gas. Electromagnetic radiation from the explosion on the surface of the sun reaches the earth. Explain why sound from the explosion on the surface of the sun does not reach the earth. Thankfully, it doesn't reach that, otherwise we would not be able to survive. The sound would so much that our permanent headache or the noise pollution would be much greater. I have already told you that sound need a medium to travel, and space is a vacuum, and so sound cannot travel through a vacuum. So that's why those explosions happening in the sun cannot be reached on the earth. That's why we cannot listen those explosions on the earth. So we're gonna write over here, space is a vacuum and sound cannot travel in vacuum, so that's why those explosions cannot be heard on the earth. So now we move to the question number 7. Question number 7 is, an electric circuit contains a battery of a fixed resistor R, a voltmeter and a thermistor. We know that voltmeter is used to measure voltage, and thermistor is a thermistor resistance decreases with the increase in temperature. So the thermistor is connected between terminals T1 and T2. Complete figure 7.1 by drawing the circuit symbol for thermistor connected between T1 and T2. So we have to complete the diagram. So this is the diagram we have connected between T1 and T2. The resistance, B part is the resistance of R is 2.5 ohm. The reading on the voltmeter is 0.4 volt. Calculate the current in R. This is the question of Ohm's law. We know that Ohm's law has a formula of V is equal to IR. So we have to calculate current in the R. The formula for the current would be V by R. V is given, that is 0.4. R is also given, that is 2.5. Dividing 0.4 by 2.5, the answer would be 0.16 ampere. So we're going to write over here 0.16 ampere. Now we will move to the other part, the power transferred in R. We know that the formula for the power is P is equal to VI. We have been given by the voltage, that is 0.4. We have already calculated I in the previous part, that was 0.16. After multiplying both, our answer would be 0.064 watt. So we're gonna write over here 0.064 watt. The next part C is the temperature of the thermistor. The temperature of the thermistor increases. Explain what happens to the reading on the voltmeter. When temperature of the thermistor, which I have already told, that uh, thermistor resistance decreases with the increase of temperature. So when the temperature of thermistor increases, the resistance of thermistor will decrease. So it is inversely proportional. You're gonna increase the temperature, the resistance of thermistor would decrease. So this is how the current will flow more, and the voltage also increases. So we're gonna write over here, when the temperature of thermistor increases, resistance of thermistor decreases, hence it will increase the current and voltage, which is also increases. Now we will move to the question number 8. Question number 8 is that figure 8.1 shows a permanent magnet attached to one end of an unstretched spring and held at rest just above a solenoid. We have been given by the figure spring north-south solenoid. The solenoid is connected to a sensitive ammeter. State the name of substance from which permanent magnets are made. So we're gonna write the permanent magnets are mostly made from steel. Okay, steel. The magnet is released when and moved downward towards the solenoid. It is released and it moves downward. When the magnet moves, the ammeter shows that there is a current in the solenoid when the magnet moves. Why is magnet ammeter showing current? Due to electromagnetic induction. Explain why there is a current in the solenoid. We need to simply explain. By relative movement of either solenoid or magnet, it will produce electromagnetic induction. This will be indicated by the deflection in the ammeter. So we're gonna write over here that magnet moves downward relative to solenoid. Magnetic flux passing through solenoid changes. What is magnetic flux? Magnetic flux is the number of magnetic lines that passes through magnetic field or electric field. You're gonna read this in A levels. This induces EMF in the solenoid. So the current will produce and it will be shown in the ammeter. So you're gonna write over here, when magnet moves downward relative to the solenoid, magnetic flux passing through solenoid changes. This induces EMF in the solenoid. Either the solenoid move or the magnet move. In this case, the magnet was moving. So due to the movement of magnet downward, it will produce the electromagnetic induction. This will change the induced EMF, and this will be indicated by the deflection in the ammeter that the current is present. So this was the question of electromagnetic induction. Now we will move to the next part. Next part is the current causes top end of the solenoid to become the S pole of electromagnet. The bottom end of the permanent magnet is in the south pole. Explain why the top end of the solenoid becomes an S pole as the magnet moves downwards towards the solenoid. Okay, this is the concept of Lenz's law. According to Lenz's law, it opposes the change what change it is causing the current. So it will repel the magnet. So Lenz's law is that whatever the change is producing, it will change that, it will oppose that change. So whatever the change it is producing, it will oppose. So we're gonna write over here, according to Lenz's law, it opposes the change causing the current. So it will repel the magnet. You can also write Lenz's law. I have written over here the direction. Lenz's law is that the direction of induced EMF in electromagnetic induction is such that it opposes the cause which is producing the EMF. The direction of induced EMF in electromagnetic induction is such that it opposes the cause which is producing the EMF. So we are going to move the next part, C part. The magnet oscillates up and down. Describe what happens to the current in the solenoid. Current, it changes the direction, magnitude and size of the current also changes, increases or decreases. Or you can simply say that when magnet speed oscillation increases, more current will induce, or if speed decreases, the less current will induce. So you can write in either way. So we're gonna write it changes the direction, magnitude and size of the current also changes it. Now we will move to the second last question of our paper, that is question number 9. Okay, question number 9 is that in a space, it is about space physics, astronomy. In space, an interstellar cloud of dust and gas collapses from a protostar. The cloud contains hydrogen. Okay, describe the energy transfer that take place as the cloud collapses and forms the protostar. Due to very strong, so we're gonna write over here, due to very strong gravitational attraction, cloud of dust and gas collapses. We know that the gravitational attraction is present between two forces. When the two objects or two masses come closer, it is directly proportional to their masses and inversely proportional to the square of the distance between them. So the temperature of the cloud of dust and gas particle will increase. Internal energy of the protostar would also increase. So this is our answer. The next part is the collapse result in nuclear reaction in the protostar that involves the isotope hydrogen 3H31. The isotope hydrogen H31 is radioactive. It decays by beta particles emission. State how the nuclei of isotope of the same elements are different. And you need to write the simple definition. They have different number of neutrons. So you're gonna write over here, they have different number of neutrons. Explain why hydrogen 3 cannot decay by alpha particle emission. Because it has only one proton and alpha particles contain two protons. We know that it has only one proton and helium particles or alpha particles have two protons. That's why they cannot decay by alpha particle emission. So you're gonna write over here, it has only one proton, and alpha particles contains two protons. Now complete the equation for the decay of hydrogen 3 to an isotope of helium. We know that beta particle has 0 and -1, and know that helium would be 0 plus 3 3 and 1 minus 1 minus 1 plus, it's going to be 2. So this is how we're going to write our answer. 2 minus 1 you can check is 1, 3 plus 0 that is 3, so you can check as well. Now next part is explain how the nuclear reaction in the protostar stop further collapse as the protostar becomes a stable star. So we're gonna write over here, due to further collapse in protostar, temperature rises. Because more friction, the temperature would rise. This starts nuclear fusion of hydrogen. It means that hydrogen is gonna convert into helium. this will be produce large amount of heat and energy as well. So this will produce an outward force, and inward force due to gravity is balanced by the outward force. So you can also write over here simply that after the collapse the temperature will rise and the nuclear fusion reaction will start to convert hydrogen into helium, and immense amount of energy which increase release, and the inward force is balanced by the outward force which was generated by the nuclear fusion reaction. Okay, C part. C part is the cloud of dust and gas that collapses also contain atoms of the heaviest element. State which part of the life cycle of a star is responsible for the production of the heaviest element. So we know that red supergiant explodes as supernova. So simply you're gonna write over here red supergiant explodes as supernova. So we will move to the next part. Next part is question number 10. Question number 10 is the last question of this paper. The isotope iodine emits two types of nuclear radiation. Gamma radiation is one type of emitted. We know that gamma radiation have highest penetrating power but low ionization power. A sample of iodine 131 produces a narrow beam of radiation which passes into magnetic field. Figure 10.1 shows some of the paths taken in the magnetic field by the radiation emitted from the sample. So the direction of the magnetic field is into the page. We can see from the cross and overwritten over there. On figure 10.1 mark the gamma. On figure 10.1 mark the gamma symbol any of the path taken by the gamma radiation. So we're gonna write over here gamma path would be like this because they doesn't bend. Okay, determine the other type of emitted radiation by iodine 131. Explain how you obtain this. We're gonna write type of radiation. Type of radiation would be beta. Explanation of this would be by using left hand rule, Fleming's left hand rule. Charged particles are going to right, and magnetic field, this is how Fleming left hand, magnetic field is into the page, thumb points the top of the page but particles bend it to the bottom of the page, so they are negatively charged. In another experiment, the beam of radiation from the sample is incident on a 5 mm thick sheet of lead. State what happens to the two types of radiation in the beam. All of beta particles will be absorbed. Some of gamma radiation may pass through 5 mm thick sheet of lead. We know that beta doesn't have that high power of penetration compared to gammas, so they would be absorbed, and but some of the gamma particles may pass through the lead. Now we will move to the last part of our question paper, B part. The gamma radiation produced has a high frequency of 8.8 into 10⁻19. The speed of electromagnetic radiation in a vacuum is 3 into 8 meter per second. Calculate the wavelength of this gamma radiation. We know that we have the formula for calculating wavelength is V is equal to F lambda. Value of lambda would be V by F. After putting those value V by F, V is equal to 3 into 10⁸ and F is 8.8 into 10 to the power 19. Our answer would be like that, 3.4 into 10 to the power minus 12 meter. This is our wavelength. Thank you for watching this video. If you do get the understanding of this paper, do let me know. If you have any queries, if any part you think that I have explained less, you can ask in the comment section. I will explain it in more detail, and I will definitely reply all of your queries. So feel free to ask any question, and if you do like this, do share with your friends and groups who want to gain the knowledge through this paper. I try to explain it in the best of my knowledge. Thank you for watching it. Do subscribe my channel and keep supporting the channel and the page. Thank you so much. Allah Hafiz.